So, based on previous science classes that you've had before and what we've talked about so far in this course, you have some experience with chemical formulas, all right? For example, table salt, I think most people would know, might know as NaCl, and its name is sodium chloride. But then there's something like water, and I think that most people would know that its formula is H2O. All right, in this unit, we're going to go a little bit more in depth in terms of chemical formulas and names, and talk about some things that you might or might not have thought about before. All right, so first of all, what is a chemical formula? All right, so the technical definition of a chemical formula is that it's an expression that tells you the types and quantities of atoms in what is called the smallest representative unit of a compound. All right. So what does that mean? All right. Well, let's take let's just use an analogy. If I were just to show you this representation right here, all right, even though it's one single picture, I think that most people would be able to recognize that what you have is actually 3 copies or 3 units of a human stick figure. All right. You don't look at this as just one unit right here. You see this as 3 separate units, all right? And each of these units, which is a person, has certain abilities, all right? And those would be the abilities of a common human, all right? So one way of thinking about it is it's the smallest bit that you can divide your sample up into, so that that little bit would have all of the properties of whatever you're talking about. So you can, if you had 3 of these, you could, divide it down to this part right here, and that is a single human. But if you were to divide it any more than that, you would not have a human anymore. All right. So if I split this thing down to half, half of a human doesn't have the full abilities of a whole human. All right. So that would be the smallest representative unit. And the formula tells you the names and parts in there. So I'm just going to use a little bit of just a generalization to say that a human is, we've got the head, we've got the torso, we've got arms, we've got legs. So the formula would be something like, we've got a head, we've got arms, but we have 2 of these arms. So I'm going to say 2 right there. We've got legs, but we've got 2 of those, and then we've got a torso. And anytime you only have 1 of something, you don't put the ones in. So the definition of a chemical formula is a little bit different between ionic compounds and covalent compounds. And that's because, if you remember, ionic compounds exist as continuous repeating units of ions, all right? And recall that is called the crystal lattice arrangement. Right. So remember, if you have an ionic compound like sodium chloride, what you actually have is an alternating pattern. All right. So if you pictured a crystal of table salt, all right, and we know that it's NaCl, we know it's sodium ions and chloride ions, but it's not like you have, a 1-to-1 ratio of unit of sodium chloride over here with space between it and another unit of sodium chloride over here. You have this alternating pattern, which we called a crystal lattice. All right. So the thing about it is, what defines a single unit of sodium chloride can be a little bit ambiguous. So just for example, what I've shown here is just a little bit of one of the faces of those crystal lattice. All right. I can't draw this 3-dimensionally. And I'm not even going to make an attempt to do that. But if I were to show this arrangement right here and just say, hey, can you circle the units of sodium chloride in that crystal lattice arrangement? Well, one person might say, well, yeah, looks like I've got a unit right here. That's a 1-to-1 unit of sodium to chloride. And right here is another 1-to-1 unit of sodium chloride. All right. But the thing about it is, I could show this exact same arrangement to somebody else, and they might say, well, when I look at it, this right here is a 1-to-1 unit of sodium chloride, and this right here is a 1-to-1 unit of sodium chloride. All right, and the thing about it is no one's right and no one's wrong. All right, it just depends on how you look at this. But there's one thing that both people could agree on, and that is within that lattice arrangement of sodium and chloride ions, there are 2 units of sodium chloride. All right, it's just that there's different ways that you could define what those units are. All right, it's a little bit less ambiguous when you have covalent compounds. Remember that covalent compounds exist as groups of atoms that are connected to each other through covalent bonds. All right, so if I showed this arrangement of atoms to people, there's only one way people could define the different units of the compound. You would say that this right here is a molecule of water, and this right here is a molecule of water. All right, notice it's not a, everybody would agree on that. That this right here would represent 2 units of H2O. So one way that you can think about what defines the simplest repeating unit, or the smallest representative unit, and you can use those terms in individually, smallest or simplest, is to think about a taste test. All right, and that is what amount of a material, what is the smallest amount of a material that you could have which would still have the chemical properties of the overall original substance. All right, and if you think about it, the taste of an object is a chemical property. It has to do with how the atoms interact with your taste receptors. All right, so let's think about, like, if we had a crystal of salt. All right, we know that that salt is made up of a crystal lattice of these alternating units of sodium chloride, which, if I were to do a more accurate representation, would look a little bit more like this. But theoretically, if I had this arrangement of sodium ions and chloride ions, would be a small little bit of a crystal of salt. All right, and even though it would be really, really hard to detect, right, on its smallest level, this arrangement of atoms right here would taste like salt. All right, and that's because this arrangement right here contains the units that have everything necessary to have the chemical properties of sodium chloride. All right, but is this the smallest amount? All right, and the thing is, you could take this arrangement right here, let's say that we broke it down the middle right here, so that we only had the top half right here. Right, and if we did this, we would have this unit right here. And if you were to take these 2 atoms, put them on your tongue, it would still taste like salt. All right, it still has everything necessary to have the chemical properties of the original compound. All right, so no matter whether you had it like this or had it like just this part of it right here, you still have sodium chloride. All right, so this little unit right here would still have all the properties of the original compound. So could we break it down a little bit more? So could we break this down the middle, and that would give us, all right, and so if you broke that apart, you would have an individual sodium and an individual chloride ion. All right, and individually, these things, if you were to taste them, would not taste like salt. All right, even though they're so small that you probably wouldn't be able to taste them anyways. Individually, they don't have the same properties as this right here. But this thing individually has the same properties as this larger arrangement here. All right, just like you could take a big crystal of salt, all right, and that's going to taste the same as if you were to crush it up and taste the smaller crystals. The properties are still the same, you just have smaller amounts of it. All right, so the question is, what is the smallest representative unit here that has all the properties of the compound? All right, it's not this, because we could break it apart to this, which is just like this. But if you go any further, it's not going to be the same. So the smallest individual unit would be this right here. All right, so that's going to be the smallest representative unit. And therefore, when we're going to give a name to what this compound is, its name is, sorry, not a name, but a formula, it's NaCl, because that is the ratio of atoms in the smallest piece of that compound that still is that compound. In the same way that this is the numbers of things that are in the smallest piece of this picture, which is the smallest individual unit that you just have repeat copies of. All right, so let's apply this to covalent compounds. So we're going to go through this same little exercise, and instead of doing it as a taste test, we're actually going to do it as a bleach test. All right, so what I've shown you here is some hydrogen peroxide. I haven't mentioned what the formula is, but let's see if we can define the smallest representative unit based on its chemical properties. All right, and one of the chemical properties of hydrogen peroxide is that it can bleach hair. So in case you don't know, hydrogen peroxide is one of the common chemicals that they would use to bleach hair. All right, so if you've ever seen somebody that's got a darker colored hair, but then there's a very, very lighter colored hair right next to that, that was most likely done with something containing hydrogen peroxide. So instead of a taste test, what we're going to ask is, what is the smallest bit of this chemical that would still have that property of being able to lighten the hair color? All right. So if we had these units right here, all right, that would definitely be able to bleach hair. All right, so could we break this thing down the middle, and let's just say that we have one of these things right here. And the thing is, that would also be able to bleach hair. All right, so could we break that down? Could we break this down the middle? All right, so that we just had, like, say, half. So break this down the middle so that we had just had half of this arrangement right here. So if you broke it down to just this unit right here, that would no longer be able to bleach hair. This unit right here does not have the properties of hydrogen peroxide. So what defines the simplest representative unit of hydrogen peroxide? It would be this bit of it right here. You need this unit of hydrogen, single bonded to oxygen, single bonded to another oxygen, single bonded to a hydrogen. That is the minimum part that is required to be hydrogen peroxide. All right, so the formula then is going to be what are the atoms within that representative unit. And so if you look at that, well, there are 2 hydrogens and there are 2 oxygens. All right, so it would be H2O2.